So the origin of all of this was in some pictures that Austin and I made. I think Austin probably made them first. But when we were doing this project on how we could use motifs and spectral graphs theory stuff, and we wanted to make pretty pictures, and so what we found was that if you built these motif-based adjacency or motif-weighted adjacency matrices, is that what we ended up calling them? Or
yeah,
that you got nicer looking spectral embeddings. And so then we didn't really talk much about that in that paper because our point was something different. But then at some point, Caitlin Kennedy, who's not here, unfortunately, was an undergrad in my numerical methods class and then wanted to do an honors project with me in this space. And so I said, well, we made a lot of pretty pictures. Let's see if we can make more pretty pictures. And so she did a really fantastic project on basically showing that you can make more pretty pictures of graphs. And I guess I didn't say that these were pictures of graphs, of course. And so Caitlin did that.
Which year was that?
Ooh, you really want me to look? It's been a while.
Okay.
So the problem is when you have kids, you just cease to remember time. You just really don't.
We started making these plots at SciM data mining in 2015.
Well, you had made some before that even.
I made a couple before that.
Yeah, but during one fantastic talk at SciM data mining that Austin and I have zero recollection of because we sat in front of my laptop repeatedly executing commands in MATLAB. This is back before I converted everything in the world to Julia, actually.
Wow.
So it's that long ago.
It's a different time.
It was definitely a different time. Okay, so anyway, yeah, this is probably circa 2016, 17, I want to say. I actually have a picture that I took. It's probably in our Slack channel, but let me see if I can pull. Oh, it's on that computer, so that's not going to help. But I can get a picture where I'm pretty sure I have a picture of Caitlin's poster. Yeah, and there we go. And okay, so then Caitlin went off to San Francisco to make lots of money, and we had always meant to finish this and write this up as a paper, but the downside to what was going, like the big bottleneck in our computation was always that we needed to enumerate the darn motifs we were looking at, and so we are reasonably good coders and are willing to spend a little bit of time looking at this stuff. But enumerating motifs is something that can be greatly accelerated with a delicate application of theory. And so Shweta, can you remind me about when your Tehran shadow paper was?
That was 2017.
2017. So right about the time, this is anyway, right about, so there were two big events in 2017. We had a second child, which makes time dilation go further bad. But anyway, the way things ended up with Caitlin was we wanted to look at larger cliques, but we didn't have really good ways of enumerating them. And so at WWW 2017, we heard about two things. One was Shweta's paper. The other one was another, I think was a direct clique enumeration code by a different team as well. And both of these seemed like ideal things to keep working on. And oh yeah. So it was about 2017 when Caitlin was graduating. And then after that, let's see, where did things go from there? So I think we did actually have something working with that other code as well. But it just didn't, it was still slow. Like it was, we needed to use lots of cores and yada, yada, yada. And it didn't work so well. anyway, things sort of slowed down for a little bit, and then Huda got interested in this project at some point. I think you had heard about it. We had talked about graph visualization.
Actually,
at some
it
point.
just happened when you remember Shweta came to Purdue to give a talk.
Oh, that's right. Yeah. We said,
yeah.
oh, you know what would be, yeah. So that was like early 20.
This
That
was, I think,
2018.
late
19?
2018. I think
Late
November
20, yeah,
2018.
late 2018.
Yeah.
So things slowed down a little bit, and then we had Shweta come out and give a talk about her trench shadow stuff, and then we said, you know, we could really put this in there, and then things just kept progressing from there, and yeah, you guys just took it and ran with it at that point.
Yeah, after that it was like, I think trying to beat the C++ code.
Oh yeah,
Yes. So
which
there
you
was
did
the
a great
battle
job at.
between Huda and Shweta. So Shweta had this fantastic C++ implementation, and Huda and me are big fans of Julia. And I said, you know, there's no reason you shouldn't be able to get it just as fast as the C++ stuff in pure Julia. Well, turns out what happened.
It was faster.
Yeah, it was.
faster than Julia.
I was definitely impressed. I mean, I didn't expect it.
Thinking Julia has to be fast. So yeah.
But that was on the Turan shadow enumeration part, where instead of directly enumerating everything, I mean, it seemed pretty clear that you probably wouldn't need enumeration, like a random sample would be entirely sufficient, and that's exactly what Turan shadow gave us. Then the next thing that Huda realized is that as the graphs get bigger and bigger, when you're doing these eigenvector embeddings, it turns out that, you know, 2 eigenvectors really isn't going to cut it for some of these graphs. And excuse me. So we needed to do multi-vector embeddings. Then we needed to reduce the dimensionality of that. And so Huda and Austin, where did you guys run into each other again?
Oh yeah, network science.
Network science, yeah.
Yeah.
In Burlington.
Right.
Yeah, you were trying to run Tisney, and I had run it in Julia just using the scikit-learn.jl package.
Correct. Yes.
So this entire video here is turning into a Julia.
It's Julia propaganda. I'll have Julia shirts on or something like that, or you can edit them in.
I have stickers.
Video.
I'll put a sticker on each of you.
Was this 2018 or 2017?
This is 2019.
This
no,
is
it should be
2019.
2019 at this point.
So things just happen, and then like a year goes by with this particular project.
It was just after I finished teaching my PhD course for the first time, and I had used the Tisney in scikit-learn in one of the Jupyter notebooks that I had in my class, and so I was all excited about using scikit-learn in Julia.
But then I think what's funny is that I think when Austin helped me out with that, he didn't know that it was for this paper.
Yes.
Yeah, that's true.
That is funny. So
yeah.
Austin and I had chatted with Caitlin about this years ago, and sort of on and off as things had been developing. But yes, I think when it was only like a month or two later, after we'd gotten T-SNE rolled in here, then we got pictures that looked good for bigger graphs, that we sort of started to figure out how to write this up. And then we got you looped back in.
Well, I had also visited Purdue in 2016, I think.
Yeah, and talked to Caitlin.
Caitlin
at length about
some
this.
of the first plots that she was
that
doing.
2016 or 2017?
Might have been 17. Again, I have no sense of time. I can go to my CV and look at the Purdue talks that I gave. I gave one in 2017, one in 2016, and one in 2014. So I gave 3.
See, the problem is it doesn't actually help us distinguish 2016 from 2017, Austin. But okay, it was probably 2017 because I'm guessing this was after she had done an initial version. We had sort of identified a bunch of bottlenecks because this also would have been right after WWW 2017, where we looked at a couple different ideas too for doing more cliques. Yeah, I'm guessing it's 2017.
Yeah, so I thought the figures were really cool, and then I didn't really think about it much more after that until until you were ready to write a paper about it.
3 years later, or
2 years later.
2 years later.
Caitlin had graduated and gone to work at Salesforce. But glad I was able to help Huda without knowing it.
Anything else we need to say? I mean, I think there's the bit about like actually drawing the graphs that they look nice and they don't take ages, but that's another that doesn't really have anything to do with this paper, although.
But also it has a Julia propaganda on it, so we'll stay within theme. Yeah, do you want to tell us about that?
So this is really getting into the weeds here, but as part of another project we'd been working on, we wanted to draw a picture of a graph. And you know, me being the perfectionist I am, I didn't want to subsample the darn edges because, you know, yes, the picture looks basically the same, but I just didn't want to have to put that caveat in the paper that I had subsampled the edges in the picture, because I guess I'm too honest in my papers or something like that. And so the issue was this particular graph had about 33 million edges, and so Julia has this nice package called Graph Recipes, which will do all sorts of nice graph layout, but the default plotting backends, PyPlot, GR, everything else would run into some sort of esoteric edge case. So for instance, I think in GR, if you set the value of an edge alpha to be less than like 0.01 or something less than 1 over 200, no, less than 1 over 255, at some point it rasterizes alpha values to 8 bits. And so your graph goes from like there to completely empty if you set it below this particular threshold. I think PyPlot would never render 33 million edges. It would just like completely choke at some point. I, at various points, tried writing out SVG files and then getting anything on the planet to render them. I waited at some point for like 10 hours for something to render an SVG file. At some other point, I had run into some code to actually do hex bins. So hexagonal bin plots or hex bin data. And I thought, well, you know what? We can just draw all the edges ourselves, and I can like literally like put pixels along each edge. And so we essentially have a custom rasterizer on a hex bin plot that will actually draw exceedingly large numbers of edges in Julia. And the cool thing about this is you actually get vector data back. So it gives you the little like hex tiles, so you can change things on the alpha value without re-binning everything. So if you do want to do interactive stuff, it's got a few niceties like that. But yeah, so it turns out we needed that for this project too. And so when I saw your pictures without the edges, I'm like, no, we really need the edges in there, because there's a lot of like subtle information, because like if the way the plots look is that they're groups, but then there are actually edges between the groups, and those edges between the groups are meaningful. And so you kind of want to see if they're there or not. And so you get these like ghostly filamentary structures, and it's super cool. And anyway, yeah, so behind the scenes there is this weird hex binning stuff that I would totally redo again, because there's no reason to do hex bins. And we should really do anti-aliasing, but I was in a hurry, didn't want to do anti-aliasing and all sorts of other little things. But yeah, that's how we ended up drawing the plots.
So as a test case, I actually showed Catherine this figure that I'm sharing. This is the Cornell embedding, and I said, this is a Facebook network of Cornell college students from back in 2005 or something, and the colors are meaningful. Do you remember I asked you that question? Do you remember what you said? What the colors you thought represented?
I remember you showing me the photo. I don't remember what I said though. Sorry, I wasn't paying attention.
Oh, well, she correctly guessed that they were dorms, which is what they actually
Which is
are.
what they are, yeah.
It's pretty impressive, I thought. So that's a testament to our methods, even if Catherine doesn't remember guessing that.
I was wondering if we wanted to talk about some future directions. I'm not sure if you guys
No, that's
wanted to.
boring. We should talk about the reviews and like go through the reviews we got.
Yeah, we almost didn't write a rebuttal for this paper, I feel like, because we were so discouraged from the reviews.
Sorry, Shweta. Future work is of course something we should mention. But I feel like we addressed that a little bit in the paper already. So maybe,
Right. Yeah.
Although that might have gotten cut because we did have to shorten our paper.
We did, yeah, but
Bigger and faster. Those are the two things, right?
it's always
the two things bigger. It's always yeah. Well, I mean, Huda has her like order one improvement already, which is you can redo our entire thing with UMAP instead of TSNE.
Oh, yeah.
Oh, I see.
I don't know enough category theory to understand.
Okay, so actually one thing that I've been playing around with, and it's just like a fun thing to just see if it works, which is take like simple graph problems, like something simple like link prediction. You want to run page rank, and is using the Truman shadow matrix that we get, like which is step 1 from our algorithm. Is it going to improve anything?
I wrote a whole PhD thesis assuming this type of thing would be helpful. So I hope it is.
And you did call it a tool even. There's some interesting, like if you want to talk about follow-up work. So Austin's been doing a lot of really cool work on different ways of approaching hypergraphs. And there's another individual, Pan Lee, who's been doing a lot of great work on this. Who else has been doing really cool stuff on hypergraphs? There's a bunch of people. I'm just blanking on their names right now. I've got a bibliography. Like this is the problem when I get serious, is then I have to like actually acknowledge everyone. And yes, there are other people I know about you. I'm sorry that I'm not mentioning your name right now. Oh, the guy in Francesco has a bunch of stuff. And anyway, they'll come to me slowly over the next minute as I keep talking. But I mean, essentially what we're doing when we build these motif based these motif weighted adjacency matrices is we're really just forming the clique expansion of a hypergraph derived from the clique complex on a graph. And so, I mean, like an interesting thing would be to relate what like the estimate we get in Turan shadow to some property of the clique complex. I don't know if there's any type of measure of structure of these things, but if we could say we're getting like a 1/2 sample of the clique complex or something like that, that would be sort of a interesting direction. Another direction would be to actually take these cliques that we're sampling and really view them as hyper edges, and then try and use some of the different type of hypergraph embedding stuff that other people had done. I mean, that's kind of how Node Devec work, is they basically derive a hypergraph and then run, what's the name of that embedding procedure they run? It's the 2vec, like the 2vec part, but
word to vec.
Well, but the name for the it's like a skipgram model or a
skipgram. Calling the it's a skipgram model.
It's a skipgram model. Again, you could do that on the clique data instead of running the eigenvector embedding. You could also do some type of higher order spectral stuff. There's all sorts of other cool sort of hyper-y directions.
So bigger,
to
faster,
go.
and more hyper.
Bigger, faster, and more hyper. It sounds like a Mountain Dew commercial from when I was growing up. I suspect they still advertise the same way. All right.
Cool. Do you think you have enough material?
I think you've got plenty of material.
Yeah,
to, like,
I think
edit
we've been
down to something.
recording.
You could, in fact,
based on
have a double header YouTube episode where you put the talk and then there's all of us gabbing about it.
I feel like people are gonna request a podcast after this, like every Friday.
Well, if you can get Julia to sponsor it,
I want to do a podcast. I remember
No,
David, we talked
Austin,
about this in Brazil.
Well, hold on. You've heard one of the COVID symptoms, right? The stay-at-home symptoms.
That you should start a podcast is one of the symptoms. Start thinking you should start podcasts.
So as time progresses with the stay-at-home regime, the probability that anyone thinks that they should start a podcast approaches 1. Someone tweeted this a little bit ago, like 4 weeks or something, and so now we're 4 weeks. Oh yeah, for posterity here, this is week number 5 of all the COVID quarantines in 2020.
We're surviving.
I would say we're doing better than surviving. So 1 notch up from surviving.
Good.
Yeah, I guess I would agree. Yeah.
A notch up from surviving too. All right,
We're
gonna
not thriving though. Anyway.
So do a little editing, upload this to iTunes as episode 1.
Oh my God, this is gonna be.
All right, see ya.
All right,
Okay.
bye.